Hello everyone. Today we shall discuss about using algebraic expressions, formulas and rules. We have seen earlier also that formulas and rules in mathematics can be written in a concise and general form using algebraic expressions. We see below several examples. Perimeter formulas. The perimeter of an equilateral triangle is equal to 3 into length of its sides. If we denote the length of the side of the equilateral triangle by L, then the perimeter of the equilateral triangle is 3L. Similarly, the perimeter of a square is equal to 4L, where L is the length of the side of the square. Perimeter of a regular pentagon is equal to 5L, where L is the length of the side of the pentagon, and so on. Area formulas. If we denote the length of a square by L, then the area of the square is L square. If we denote the length of a rectangle by L and its breadth by B, then the area of the rectangle is L into B, or length into breadth. Similarly, B stands for the base and H for the height of a triangle, then the area of a triangle is half base into height, half BH. Once a formula, that is, the algebraic expression for a given quantity is known, the value of the quantity can be computed as required. For example, for a square of length 3 cm, the perimeter is obtained by putting the value L equal to 3 cm in the expression of the perimeter of a square, that is 4L. The perimeter of the given square is equal to 4 into 3, that is 12 cm. Similarly, the area of a square is obtained by putting in the value of L equal to 3 cm in the expression for the area of a square, that is L square. The area of the given square is equal to 3 square centimeter square, that is 9 cm square. Rules for number patterns. Study the following statement. If a natural number is denoted by n, its successor is n plus 1. We can check this for any natural number. For example, if n equal to 10, its successor is n plus 1, which is 11, which is known. If a natural number is denoted by n, 2n is an even number and 2n plus 1 an odd number. Let us check it for any number, say 15. 2n is equal to 2 into n, that is 2 into 15 equal to 30, is indeed an even number, and 2n plus 1, that is 2 into 15 plus 1, that is 31, is indeed an odd number. Let us try for different patterns. Here you see, we take a small line segment of equal length of such as matchsticks, toothpick, bricks, or pieces of straws cut into smaller pieces of equal length. Join them in patterns as shown in the figure, like this. It consists of repetitions of the shape square made from 4 line segments. As you see, for one shape you need 4 segments, for 2 7, for 3 for 10, for 3 10, and so on. If n is the number of shapes, then the number of segments required to form n shapes is given by 3n plus 1. You may verify this by taking n equal to 1, 2, 3, 4, 10, etc. For example, if the number of shapes formed is 3, then the number of line segments required is 3 into 3 plus 1, that is 10, as seen from the figure. Now consider the pattern in figure 12.2, this figure. Here, the shape is U is repeated. The number of segments required to form 1, 2, 3, 4 shapes are given as 3, 5, 7, 9 respectively. If n is the A stands for the shapes formed, the number of segments required is given by the expression 2n plus 1. You may check if the expression is correct by taking any value of n, say n equal to 4, then 2n plus 1, 2 into 4 plus 1 equal to 9, which is indeed the number of line segments required to make 4 use. It is 2n plus 1. You can make similar patterns and find the formulas for that. Right? Some more number patterns. Let us now look at another pattern of numbers. This time without any drawing to help us. 3, 6, 9, 12, 3n. Numbers are such that their multiples of 3 arranged in ascending order, beginning with 3. The term which occurs at the nth position is given by the 3n. You can easily find the term which occurs in the 10th position, which is 3 into 10, that is 30. 100th position, that is 3 into 100, and so on. Pattern in geometry you can also find. What is the number of diagonals we can draw from one vertex of a quadrilateral? Check it. It is 1. From one vertex of a pentagon, check, it is 2. It is pentagon. Right? It is 2. From one vertex of a hexagon, it is 3. Right? The number of diagonals we can draw from one vertex of a polygon of n sides is n minus 3. Check it for a heptagon 7 sides and octagon 8 sides by drawing figures. What is the number for a triangle 3 sides? Observe that the diagonals drawn from any one vertex divide the polygon in as many as non-overlapping triangles as the number of diagonals that can be drawn from the vertex plus 1. Right? These are the different forms or patterns in geometry. Now also I'll discuss various exercises to solve the problem. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.